Hello students, in this video we are going to discuss about mesh analysis. It is again one of the methods that is used to calculate unknown currents in any given circuit. Like we were using nodal analysis to calculate the unknown voltages. Similarly, mesh analysis is used to find out unknown currents. And it is based on KVL, that is Kirchhoff's voltage law. Now before we start with the steps and we'll be solving one numerical, we must first understand what a mesh is and how is it different from something called as a loop. If we take suppose one example, we will call these nodes like this. Now if we see how many loops we are having here, so first let us discuss what is loop. Loop is any closed path. Any closed path that you are traversing is a loop. Suppose I am starting from node number A, and while I am traversing a path from A to B, B to F and coming back, so this is my loop. So I can say this is also one of the loops. Similarly, if you are traversing a path like this, starting from A, B, C, then you are coming back like this, it is again a loop. So it does not matter which path you are traversing, as long as you are returning back to the original position, it is a loop. Similarly, this big one, again we can say it is a loop because it is creating a closed path. So this is what is a loop. But can you tell me what is mesh? Mesh is again, it is a loop. It's a loop inside which no other loop exists, inside which there is no other loop. So this is a condition. So if we again analyze, we can say that this particular path is a loop, but it is not a mesh, because inside this there are other loops also. So this is how we differentiate. A loop is a bigger path also. It can be this one also is a loop, or we can say this bigger path is also a loop. But mesh means inside of which there must be no other path. If we talk about this one, it is a mesh, it is a loop also. So can you answer me how many loops this circuit is having and how many meshes this circuit is having? Number of meshes are, you can see 1, 2 and 3. So only 3 meshes are here. And what about the loops? So the meshes that we have written, they are also a part of the loop, plus there are few other ones also that we can consider as a loop. Like suppose this one, it is a loop. So this is the fourth one. Similarly, I can say this fifth one is also a loop, and then we can have the overall one also, that was the bigger one that we have shown. So we can say there are, in total there are 3 plus 3, that is 6 loops. And since every mesh that you are having is also a closed path, so we can say every mesh is a loop, but every loop is not a mesh. Okay, so this is how we have to differentiate Now this method is based on mesh analysis, means once you are writing this KVL equation, it must be applicable only to mesh, not the loop. And the steps that we have to follow are very simple. What are the steps we follow? So this is the basic of mesh analysis. Let us understand this with one example. The example is here. The question given to us is we have to calculate mesh currents. As you can see here, there are if I ask you first, how many meshes can you see? So what is a mesh? Inside which there exists no other loop. So what about this path? It is a mesh because inside this there is no other loop. What about this path? Again it is a mesh because inside this there exists no other path. So we can say number of meshes are 2. So how many loops? Already we are having 2 here, plus we are having this bigger one. This bigger one is a closed path, so it is a loop, but it is not a mesh because inside of this there are other loops also. So number of loops are 3. So we are concerned about the meshes. So you should know that number of currents that we have to calculate is simply equal to number of meshes here, is equal to the number of meshes. So there are 2 unknowns for us in this equation. So let us apply step number 1, that is assign currents. So let me assign currents randomly. So let me call this one as I1 and this one as I2. I have taken it as clockwise. If you are wishing to change it anti-clockwise, you will still get the same answer. Now after this, once we write the equation, we will start with mesh number 1. So we would write the simple KVL equation, that is 45 is 2I1 plus 12 times I1 minus I2 plus 4I1. So while we are applying KVL, as you can see, in this 2 ohm there is only one current, that is I1. In this 4 ohm there is again only one current involved, that is I1. So that is what we have written here. And similarly, if we see this particular resistor, this is common between I1 and I2. So both currents are involved here. And if we look at the current directions are opposite. Your I1 is coming this way and your I2 is going upwards. So they are opposite in direction. And since my reference is mesh number 1, so we should write I1 minus I2. So this is my first equation. Now if I come to mesh number 2, what would be my equation? So you can start from any of the branch, it does not matter. So I can write 12I2 minus I1 plus 9I2 plus 30 plus 3I2 is equal to 0. Again, if we see here, this 12 ohm is common between I2 and I1, but your reference right now is mesh number 2. So it would be I2 minus I1. Then if we see in 9 ohm and 3 ohm resistor, there is only one current involved, that is I2. So we have written here only I2. And we are having a 30 volt source, again going from plus to minus, so it is a 30 volt here. So these are the 2 equations that we have derived. Then we can rearrange it so that we can use that Cramer's rule to get the answer. So if we see at the first equation and the second one, after simplifying it a bit, what we would get is first equation as 18I1 minus 12I2 is equal to 45, and in the second equation you would get 12i1 minus 24i2 is equal to 30. So these are the two equations. Now you can solve them. To calculate I1 and I2. While you will solve, your I1 must be 2.5 ampere and your I2 must be 0 ampere.